Alright guys, now we're looking at Hamiltonian circuits. So we've talked about Euler circuits, now we're looking at what's called Hamiltonian circuits. The first thing we're going to look at is planning a trip around the world by visiting each city exactly once and using only the identified routes to travel from city to city. The dashed lines represent routes on the opposite side of the globe. So here's that picture. And you see here that from one city there's multiple paths to go any direction to another city, and these represent the routes that you could travel from city to city. So what we're trying to do is visit each city exactly once. Now if you notice, the cities represent a vertex, and then the route between the cities are the edges. So all we care about here is making sure that we have visited every city. So as an example, there's multiple examples, but as just one example, we're going to go from Chicago, or from San Francisco to Chicago, down to New York, New Orleans, and Tijuana. And so I visited each city in this little situation right here. And so now I need to go out along the edge of the circle. So we'll go up to Santiago, and then we'll go around Cape Horn, Casablanca, Madrid, Paris, London, Fargo, Fairbanks, Honolulu, Brisbane. Now we go to the opposite side of the globe where we see Hong Kong, and then we can go either direction. We can look at Tokyo, Moscow, Istanbul, Madras. So we visited each city exactly one time. So now that we visited each city exactly one time, we need to think about what does it mean to be a circuit. Now remember when we talked about Euler circuits, that was beginning and ending at the same vertex or the same spot. Well, for Hamiltonian circuits, it's the same thing. So I want to see if we can find a path through this identified routes to all these cities, and from the city we start at, I also want to end there. So I mean, suppose we live in San Francisco. Well, when we get done with our around the world trip, we want to be back home in San Francisco. So let's start with San Francisco again. And again, you do not have to start with San Francisco. It's just where I choose to do it. So if we start there, we can go again to Chicago, New York, New Orleans, and Tijuana. And it's the same route that I started with earlier. And this time we're going to go out to Santiago and then up to Brisbane. And now we'll go on around the Tokyo, Hong Kong, Madras routes. So we go up from Hong Kong to Tokyo, Moscow, Istanbul, and Madras. And what this does now is this takes us to Cape Horn, and we can go all the way around these outside identified routes. And when we get down to Honolulu, we can make it back to San Francisco. And so what we just completed there was a circuit by beginning and ending at the same vertex. You'll also notice that several of these edges went unused. We have this edge here, this edge, so on and so forth. Many of these edges didn't get used in this graph. You need to, from this point on, when we talk about Hamiltonian circuits versus Euler circuits, you need to make the distinguishing factors between the two very well known, that Euler circuits deal with edges and Hamiltonians deal with vertices. So here we see that definition: a path on a graph that goes through each vertex once is called a Hamiltonian path. A path that starts and stops at the same vertex and goes through each vertex once is called a Hamiltonian circuit. So that first route we saw, where we ended at a different vertex than San Francisco, was called a Hamiltonian path. But then that second one, this one right here, was called a Hamiltonian circuit. So which of the following Hamiltonian or which of the following graphs have a Hamiltonian circuit? So again, we need to begin and end at the same vertex. So if we begin at that vertex, we can go around this square, and we ended at this vertex. So this one is a Hamiltonian circuit. With the next one, again, it does not matter which edge we use, or it does not mean we have to use every edge. We can leave some edges out. So this is that exact same picture, except we have incorporated this edge and this edge to the picture, to that square. Well, that doesn't mean we have to use them. So we can just go around the square, and we have visited each vertex exactly once. So this one is also a Hamiltonian circuit. And you'll notice I didn't use all the edges, because you do not have to use all the edges when you have a Hamiltonian circuit. This one here, this one's a little bit more tricky. So if we start here, let's see what we can get when we go around. Okay, so it looks like I have a Hamiltonian path, but not a Hamiltonian circuit, because my beginning and ending spots are different. I believe that you can do this a few ways, and anybody that can prove me wrong here, I'll give them a free pass for homework. But this one is not a Hamiltonian circuit. And then this last one here. Let's see if this one is a Hamiltonian circuit. We go around the outside, hit those three, and then from this vertex we'll go to the inside and hit those three, and then we can come back to that vertex we started at. So this one is also a Hamiltonian circuit. So here's the three circuits that we have of the four graphs that we were given. So the last thing I want to do is compare and contrast Euler circuits, see what they have in common and see what they have that's different. So the thing they both have in common is that they got to begin and end at the same vertex. That's essentially the definition of what a circuit is in general, not just an Euler or Hamiltonian circuit, but any type of circuit. Basically begins and ends at the same spot. For Euler circuits, we're going to use each edge exactly one time. Now guys, this is extremely important that you remember Euler circuits use the edges exactly once. And then with Hamiltonian, we have that the graph uses each vertex exactly once. So with Hamiltonian circuits, we use each vertex once. Euler circuit use each edge once. They are very different things. Something else that we might have is that Euler circuits might use the vertices multiple times. So you may visit the same vertex more than once. And Hamiltonian may not use some of the edges. As we witnessed earlier, you do not have to use all the edges in order for you to have a Hamiltonian circuit. So there's some differences, there's some comparisons for Hamiltonian and Euler circuits. It's very important that you be able to distinguish between these two for quiz and test questions and for applications that will inevitably arise.